Hello my dear students, welcome to the class of 11th English medium. The subject is statistics, chapter 6, permutations, combinations and binomial expansion, brought to you by Vitan sir. In the previous video, which you can find at the top right corner of your screen, we completed certain sums starting from question number 1 to question number 8 of the exercise 6.1, and in this tutorial we are going to continue this exercise. So question number 9, using all the digits 2, 3, 5, 8, 9, how many numbers greater than 50,000 can be made? Okay, now the question here is that I have to use numbers 2, 3, 5, 8, 9 and arrange them such that the answers should be greater than 50,000. Now here the main important place is the first place. That means if I want to create numbers greater than 50,000, the values at my first place, I'm talking about first place, that means the values at this place should be greater or equal to 5. That means if I put 2 in here, it will be something around 20,000. If I put 3 here, it will be something around 30,000, and both of these will be less than 50,000. So if I want to create numbers greater than 50,000, I should put 5, 8 or 9 at the first place. So I'm going to divide this question into two parts. First of all, I will find the permutation for first place and then for the remaining places. So the options which I have for putting at the first place are three options. I don't have five options because 2 and 3 are not applicable here, because I want values greater than 50,000. So if I put 5 or 8 or 9 at the first place, I can get values greater than 50,000. So three options and any one is to be put. That means 3p1. Next, after putting one value on the first place, I will be left with four values. Okay, I'm only going to put one out of these three at the first place. Remaining four values will be put at the remaining four places. That makes it 4p4. So just getting this permutation values is important, because after this you already know how to solve the values, right? So 3p1 is 3, 4p4 is 4 factorial, which is 3 into 24, which is 72. So this is your total arrangements of digits 2, 3, 5, 8, 9 to get a number greater than 50,000. Moving on to the 10th question, a person has 5 chocolates of different sizes to be given to 5 children of different ages. If biggest chocolate is to be given to the smallest or the youngest child, in how many ways can these chocolates be distributed? Now here the question is not uh, biggest to be given to youngest and then in the descending and ascending, or just the biggest chocolate. These are the 5 chocolates and these are the 5 children. So the biggest chocolate is to be given to the youngest child, and remaining we can give to anyone. So that means that the first chocolate, this big chocolate one, is to be given to one, and that makes it 1p1, and remaining 4 chocolates to be given to remaining 4 children, that makes it 4p4. It's simple as that. So 1 into 4 factorial, that is simply 24. So the answer here is 24. Okay, so when we give biggest chocolate to the youngest child, mm, we get 24 options of distributing these 5 chocolates between between these 5 children. Okay, it was a simple question, not a big one. 11th, how many arrangements can be made using all the letters of the following words? Now there are three sub questions here. The first question here is the word statistics. Now usually when we calculate the number of characters here, they are 10. So if we want to just arrange them, find the total arrangement, it will be 10p10, 10 factorial, and we will get that long 36 lakh something answer. But there is a small problem here. Some characters have been repeated, and when these characters are repeated, that means whether they are placed at one place or another place means the arrangement is same. So actually we can't directly calculate 10 factorial. Let's make a list of which characters have been repeated. S has been repeated 3 times, T has been repeated 3 times, and I has been repeated 2 times. Single characters doesn't matter, but those characters which appear for more than one times must be mentioned here. So S has been repeated thrice, T thrice, and I twice. We need to change our calculation somewhat because there are repetitive characters. So whenever in a word we need to calculate total arrangements and there are certain repetitive characters, what you need to do, the total characters are 10, so 10 factorial and divide by these repetitive factorials. So in the numerator I will write the total characters 10 factorials, but because this S has been repeated 3 times, divide by 3 factorial, T has been repeated 3 times, divide by 3 factorial, and I has been repeated 2 times, so divide by 2 factorial. So these many arrangements will be reduced because they are the same. So whether I take this T and put it here, it is going to be the same thing because they are the same characters. Okay. So this is a method of calculating arrangement for similar values. So we just expand this. The last I'm going to write 3 factorial because with this 3 factorial I'm going to cancel it directly, and remaining values I have expanded. So when you multiply and then divide with these values, you get your answer as 50,400. So when I take the word statistics and arrange it as I want, I get 50,400 total arrangements. Similarly, I have the word here bookkeeper. Once again, I have to make a list of characters which has been repeated. O has been repeated twice, K twice, and E thrice. As you calculate the number of characters here, you get 10 characters and it will be divided by 3 factorial, 2 factorial, and 2 factorial. So once again, I'm going to expand it up to 3 factorial, divide by 3 factorial, and then expand this both 2 factorials. Multiply these values, divide by these values, and you get 1,51,200. So that's your answer. When we arrange the word bookkeeper, uh, take the letters of the word bookkeeper and find the total arrangements, we get 1,51,200 arrangements. Similarly, third question has appearing in it, and thus in this word A appears 2 times, P appears 2 times. That's all. So 9 factorial, because 9 characters are there, divide by 2 factorial into 2 factorial. So 9 up to 2 factorial, divide by 2 factorial into 2 into 1, multiply all these values and then divide by these values, you get the answer 90,720. So my dear students, when the characters have been repeated in the word, you divide those repeated characters as factorial values from the total character factorial value. That's your method of solving this. Okay, here you don't need to do that n factorial upon n minus r factorial sequence because these characters have been repeated. Divide this repetition factorials from the total character value factorials. Okay, practice this properly. Okay, moving on. Question number 12. What is the ratio of number of arrangements of all the letters of the word Ashok and Gita? Chalo, let's write down the words Ashok and Gita first. Now looking at the word Ashok, there are 5 characters and I need to calculate its total arrangement. And as you can see from the word Ashok, there are no repetitions. So simply 5 factorial. Because 5 characters are there, it will be 5p5. So I will call it 5 factorial. For the word Gita, similarly, we have 5 characters, but E has been repeated twice. That makes it 5 factorial divide by 2 factorial. I hope you guys are getting this properly. Because in Gita, 5 characters are there, 5 factorial will be the total arrangements, but because E has been repeated 2 times, I have to divide it by 2 factorial. And because I am dividing it by 2 factorial, we just did this in the previous question. So 5 factorial will be 120, but 5 factorial upon 2 factorial will be 120 upon 2, that is 120 and 60. And when we simplify this, we get the ratio as 2 is to 1. Okay, so the ratio of the number of arrangements of all the letters of the words Ashok and Gita is 2 is to 1. Simple reason that in the Gita E has been repeated twice, so it has been divided by 2 factorial. Therefore, Ashok, the number of arrangements of letters of Ashok are twice that of Gita. Question number 13. There are 5 seats in a car, including the driver's seat. If 3 out of 10 family members know how to drive, then in how many ways can 5 out of 10 persons can be arranged in the car? Now, this is a car, okay? Just accept it. This is a car. Now in this car, this is your driving seat, and in the family of 10, only 3 people know how to drive. Now whenever we are talking about a car, the drivers are the most important people. It doesn't matter who sits in the other seats, but in the seat of a driver must sit there. Anyone else who does not know driving should not sit in a driver's seat. So whenever we are arranging people, first we should arrange a driver. So out of 10 family members, 3 people know how to drive. Now 3 people can't drive together. That means out of 3 people, any one person is going to drive here. So we have out of 3 one option. So first we are going to solve that driver's equation, that is 3p1. Now out of 10 people, one person has sat on the driver's seat. So remaining are 9 people, and we are left with 4 empty seats. So out of 9 people, 4 empty seats are there. So 9p4. So I hope you guys are getting this, how we do this. Okay. So first we arrange the driver and then we arrange the remaining seats. So 3p1 because 3 drivers are there, and because one person has sat on the driver's seat, 9p4 because remaining are 9 people and remaining are 4 seats. So 3p1 is just 3 while 9p4 is starting from 9 ending at 4 values. So 9 into 8 into 7 into 6. And when you multiply all these values, you get 9072. So the answer for this question is 9072. Okay, so use your logic whenever you are solving the permutation kind of questions. Question number 15. Now, if you are thinking why I skipped the question number 14, question number 14 is a very specific kind of a question, and I believe I will just create a specific tutorial for explaining how to solve the question number 14 itself. For that purpose, you will have to wait. In the future, I will create a tutorial before ending this chapter, but that will be specifically for solving sums based on question number 14. Some extra knowledge is to be given to you guys who does not know how to handle a dictionary, proper dictionary, and how to search a word in that. And using that content, I will explain how to solve that sums of question number 14. So right now I am skipping this question. I will prepare a separate tutorial for that in the future. So question number 15. How many arrangements of the letters of the word shloka can be made such that all vowels are together? Now the word here is shloka, but in this the vowels are O and A, which are supposed to be together. So when we rearrange the word, it becomes something like this. Vowels OA are together, so we will just draw a circle here, and SHLK are the remaining characters. Now I think this kind of questions we have already solved, where uh, people are together, boys are together, and here vowels are together. Nothing new. So this together, this group of vowels I will depict as 1, and remaining will be 2, 3, 4, 5. So right now we have, rather than 6 characters, we are taking it as a 5 character value, and that will make it 5p5. Now because O and A are in a group, and in that group they can be arranged internally. 2 characters are there and they can be placed in these 2 places separately, so that will make it 2p2. So 5p5 and 2p2 will be 5 factorial, 2 factorial, that is 120 into 2, 240. So total number of arrangements for the word shloka when vowels are together is 240. So this kind of together sums, I hope you guys are understanding better than before how to solve. The last question of the exercise 6.1. 7 speakers A, B, C, D, E, F, G are invited to deliver a speech in a program one after another. In how many ways can the speech of 7 speakers can be arranged such that B will deliver his speech immediately after A? Now here B must deliver his speech immediately after A. That means A and B are connected. So what I am going to do, I am going to write down the numbers, and then I am going to write an arrow here, that B will give speech after A, and because these two have a condition between them, I am going to put them in a box, and because they are in a box, I am going to consider them as 1 at the time of calculating my actual arrangements. So here A and B together will make a 1, 2, 3, 4, 5, 6. So that would be 6p6. But usually what we do, we arrange these guys internally and then multiply it, because 2 are there, 2p2, we multiply with 2p2. But here we can't arrange them internally. The reason for that is that B will give speech after A, but according to our question, A will not give speech after B. Arranging internally means that AB or BA. Okay, first comes A, then B, or first comes B, then A, which is not possible here. Here only this system, this arrangement is possible. So there is only one arrangement. There is no 2p2. There are no two arrangements. That's why this will be our final permutation. So 6p6 will be 6 factorial, which is 720. So with this, our exercise 6.1 ends. I hope you guys understood properly the method of sums I explained. I tried some uh, drawings for better understanding and all that. Next time, I'm going to start with the second concept of this chapter, that is combination. So wait for that tutorial. Till then, complete the notes in your notebooks, and in case of any doubts, comment in the below section. You can contact me personally, and if you liked this video, give me a thumbs up. If you are new, subscribe to my channel. Thank you very much, and I will see you next time. Welcome students to Vitan Sir's Unacount Academy. That's better way to success for you. I am Vitan Vora and I teach accountancy, statistics and social science. You can contact me on my cell number 919426310184. Please give a sub to my channel and also check out my other video playlist which you can see on the screen. Thank you, and I will see you in the next video.